This is Coach Dorf. We're in section 2.2, and we're going to look at this example like a homework problem. In this one, we're looking at the limit as x approaches 3 from the left of the square root of x over x minus 3 all to the fifth power in the denominator. So first thing we're going to notice here, that 3 with that little negative sign, x is approaching that under the limit sign. That negative means that we're approaching numbers that are a little bit less than 3, or we're approaching 3 from the left. That's how it's determined. All right, so to solve this problem, the first thing I need to do is I need to look at the value of the limit at the top and the value of the limit at the bottom. So we have the limit as x approaches 3 from the left of the square root of x. Well, I just put in the value 3 there. I don't have to worry about the fact that it's going from 3 to the left at this point. I can just plug in the value of 3 and I get the square root of 3. And in the denominator, I have the limit as x is approaching 3 from the left of x minus 3 to the fifth power. Again, I'm just looking at the denominator. I'm doing an initial idea of what's happening with this function. So I'm going to plug in the value of 3. When I do that, I get a 0. Now, anytime you get a non-zero number over a zero number, or 0, then that means you only have 3 possible cases. So this is a non-zero number, and this is 0. All right. So really, this is great because that means it narrows down your cases. You only have 3 possibilities. So we have 3 possibilities for my answer. And these are, it could either be, the answer could be infinity, negative infinity, or does not exist. Anytime you get a non-zero number over 0, these are the 3 possibilities. Now, the fact that I have a one-sided limit, so because this one, x is approaching from 3 from the left, that means it's a one-sided limit, then does not exist will not happen. So my answer is either going to be positive infinity or negative infinity. The same thing would be true if it was 3, as x was approaching 3 from the right. Anytime it's a one-sided limit, whether it's the left or the right, you're not going to have does not exist if you have an equation, you have a fraction where you have a non-zero number over a 0 number. So what we need to do now is determine what sign I'm going to get in this original problem. And the way I do that is I'm going to look at the limits for both the top and the bottom. And now I'm going to look at the numbers as x is approaching 3 from numbers that are a little less than 3. So we're going to use the fact that it's a one-sided limit. And I'm going to take the sign of what I get on the top and the sign of what I get on the bottom. And then I'm going to look at those. And if the total sign of the top and the bottom together is positive, then I'm going to get positive infinity. And if the sign of the top and the bottom together is negative, then I get negative infinity. So we're looking at as x approaches 3 from the left. So that means numbers little less than 3, all right? And what happens here? So I have the limit as x goes to 3 from there, and I'm going to have the numerator and the denominator. And I want to look at the signs that I get here. Doesn't matter what numbers I have at this point, because we already know that it's going to be a non-zero number over 0. All right, so as x approaches 3 from numbers that are a little less than 3, so you can take a number like 2, 2.5, 2.9999. What's going to be the sign on the top? Is it going to be positive or negative? Well, it's going to be positive because it's just going to be the square root of whatever that x value is. And that's always going to be a positive number. If it's 2, it's the square root of 2. If x is, if I say it's approaching it from 2.5, then it's square root of 2.5. If it's 2.9999, which is a little less than 3, it's the square root of 2.9999, which is a positive number. In the denominator, let's try the same thing. So let's take a number a little less than 3. If we took 2, and I plug that into the denominator, I'd have in parentheses 2 minus 3 all to the fifth power. Now what's 2 minus 3? That's negative 1. Negative 1 to the fifth is a negative number. If I now put 2.5 in there for x, I'm going to get 2.5 minus 3, which is a negative number, to the fifth power, which will give me a negative number. If I put 2.999999 in there, subtract 3 from it, I get a negative number, put it to the fifth power, I still get a negative number. So this is always going to be a negative number as x approaches 3 from the left. Not when x is equal to 3, but anytime it's just a little less than 3. So a positive over a negative is going to give me a negative number, negative, and so that means my answer is going to be negative infinity. Because the only possibilities were either positive infinity or negative infinity, and we're just trying to figure out the sign here, and the sign is negative, so it has to be negative infinity. Now, I want to make a note here, an important thing to say. The fact that it goes to negative infinity does not mean that the limit does not exist. In fact, the limit does not exist. What negative infinity means is that the limit is going to negative infinity and it does not exist. So this limit is going to negative infinity and it does not exist. Now, why do we use the negative infinity? Why don't we just say it does not exist? Well, the negative infinity gives us a little bit more information about what happens as the limit, as x approaches the number for the limit there. In fact, if it goes to infinity or negative infinity, that means that we're going to have a vertical asymptote. And so that helps us determine that we have that because we have that infinity or negative infinity. All right. So again, you can have a problem where a function, the limit doesn't exist, and it doesn't exist for various reasons. But you could also have a case where the limit does not exist and it goes to infinity, in which case we would just say that the limit goes to infinity. Or you could have a case where the limit doesn't exist and it goes to negative infinity, in which case we would just say it goes to negative infinity, like we did here. So when it says negative infinity, it means the limit is going to negative infinity and it does not exist. Now let me just do a variation on this problem. Suppose the original problem were changed just a little bit. Suppose now we would have the limit as x goes to 3 from the right of the square root of x over x minus 3 to the fifth. What is the value there? Well, just like in the previous problem, if I plug in the 3 in the numerator, I get a positive number. I get a number that is non-zero. So we have a non-zero number. And if I plug in 3 in the denominator, I get 0. And so that means I've got 3 possibilities: infinity, negative infinity, or does not exist. And because it's a one-sided limit, it's going from 3 to the right. It has a little plus there after the 3. It does not exist is not a possibility here. And so it's either going to be positive infinity or negative infinity, and I just need to figure out the sign. So in this case, we're looking at x approaches 3 from the right, or x is approaching 3 with values a little larger than 3. What is this? What are the signs I get? So in the numerator, and I have the denominator, what happens in the numerator? Well, in the numerator, I have the square root of x. So I'm putting in a number a little bit larger than 3. So that could be like 4, it could be 3.5, it could be 3.000001. If I take the square root of that, it's always going to be a positive number. We've already figured out, we don't need to know what the number is, we just need to know what the sign is. It's going to be positive. And in the denominator, if I take a number a little larger than 3 and I put that into the denominator, so if I took 4 and put it into the denominator, I had 4 minus 3, which is 1. 1 to the fifth is a positive number. If I put 3.5 in there to the denominator, I get 3.5 minus 3, which is 0.5 to the fifth power, which is a positive number. If I put 3.000001 to the denominator, then I get 3.00001, I think that's the right number of zeros, minus 3 to the fifth power is a positive number. Doesn't matter what the number is because we've already looked at that case. So a positive over a positive is going to give me a positive. And so this implies my answer is going to be positive infinity in this case. And again, that means the limit doesn't exist, but it gives me more information. The limit doesn't exist and the limit goes to infinity, but infinity is not a number. All right, hopefully that helps you. Thanks.